Today we are going to talk about something interesting, which is SQL Server and Sybase to Postgres, right? So I am Avinash Vallarapu. I am the CEO and Chief of Products at HexaCluster, and also we are basically the creators of Vallarapu PG and a lot of other tools and extensions. And I carry more than 20 plus years of experience in database migrations and also Postgres and several other databases. And at the same time, we have Suman Michael, who is also going to share the stage with me. So Michael, he's the Director of Research and AI. So anything related to AI is actually taken care of by Michael, and of course migrations too. But anything that you want to add, Michael, I probably hijacked this.
Yeah, so we have been working in the common intersection of AI and database migrations these days and database optimizations. So that's where we would need a special track of research and all these studies to put forth to get more feedback from the community and get going this forward.
Yeah, great. So so the interesting thing about SQL Server and Sybase is that, as you have seen in the first slide, shared roots, but slightly different migrations, right? So I think the history speaks about how Sybase and SQL Server are more related, and how at some point SQL Server got diverged and got recreated from the same roots as Sybase, and you still have the same similar shared TDS protocol and the T-SQL dialect between Sybase and SQL Server. But since the acquisition of Sybase, which is now SAP ASE, right? There have been some interesting discussions everywhere across the internet about Sybase ASE licensing. The support challenges where people are actually looking for alternatives. Some probably would look for SQL Server as an alternative, and sometimes people are also looking for more modernized open source platforms like Postgres. And at the same time, even SQL Server workloads, interestingly, we can see that there is a lot of interest on migrating to Postgres, or Postgres supported on DBaaS platforms. So we have also been seeing a lot of interest in SQL Server to Postgres and Sybase to Postgres, and during that point, we have a lot of research put in place, even while we had to build our tooling to support this. So we're going to talk about some of those aspects in this presentation. So I think from architectural perspective, as well as locking and concurrency internals, right? In case you haven't, you may be definitely familiar about Postgres and how MVCC works in Postgres, right? Where the concept is all about readers never block writers, writers never block readers. And so, for example, if you run an update on a row, right? So there is a row level lock that you see, but not a page level lock or an entire table level lock in Postgres, right? MVCC handles it. But if you look at Sybase, the history of Sybase, right? So you had the concept of APL, all pages lock, and in Sybase 11, the introduction of data only locks so the concept of data only locks got introduced. So what happens is, you run an update, right? It actually locks the entire page. Page is nothing but the data block, right? And data only lock also had got two different modes. Data only locks basically around data rows and data pages. So data rows is somewhat similar to the MVCC in Postgres, but there is still a lock escalation when you have a certain amount of concurrent updates hit, right? It again escalates to probably cascades to probably an entire table level lock. So in such a case, there are certain thresholds and certain trade-offs that DBAs have to look into and fine tune it with respect to Sybase. And SQL Server as well, with respect to row level locking, while there is definitely a lot of equivalence when compared to Postgres, right? You still have a certain lock escalation which is similar to Sybase at some point when you actually get to a certain amount of activity, right? So at the same time, you do not have like when we talk about versioning in Postgres, when compared to any other database, you do not have a global undo area where your older versions are really getting stored for a certain amount of time or for a certain amount of size, right? So you actually have the tuple versioning in heap. So but there is some people say that it's an overhead of vacuum. Yeah, it can be an overhead with vacuum, but there is also there are some beautiful concepts in Postgres such as fill factor and at the same time hot, which originally when got introduced it was heap overflow tuples, and I think after that it's heap only tuples, right? So where I think 8.4 8.3 right, Jim? So it was basically Postgres tried to introduce a similar overflow area, right, for storing the undo versions, but later that got changed immediately, right? So yeah, so ultimately, yeah, MVCC really wins with respect to Postgres in architecture as well, concurrency as well as locking perspective. Yeah, and yeah, so when we are doing data type mapping between be it SQL Server to Postgres, right? Today, I don't think that, especially with respect to SQL Server to Postgres, you have much of a challenge in data type mapping. You have a good amount of data type compatibility in Postgres for all the SQL Server types, but some kind of a careful attention has to be taken, especially when mapping certain types, right? So you want to say something about that, Michael?
Yeah. So these are the defaults that the migration experts opt, but you should be really careful for what you're opting. So if you take date time, so you'll be missing the millisecond precision, and you should use the alternatives like a date time 2, or you should use some extensions. We'll be sharing them in the next slides. And then if you are watching out for money or small money, then you should watch out for the fixed point precision, and the very key area caveat where you should be really careful about money is the rounding off errors. So it can round off over time, especially with the window functions and aggregate functions, and that could really go off the charts there. And the semantics of having n varchar, so the bytes versus chars, so you should be dealing that carefully. And bit boolean, so now it's better than earlier. And we have SQL variants, hierarchical. So for the hierarchical queries, you will be using IT extension, but we suggest to translate them to native queries, so for better planning and better execution times. And then you have unique identifier, so now we have UUID, and then I think PG18 has got UUID v7, which is has got better indexing, so because it's arranged temporally. And we have tiny int, small int, so yeah, so these are the things that should be watching out, which really matters when you're talking about indexing on them, when you are doing business critical like a medical or finance applications where these rounding of errors and these all compound and show very late in the assessment, in the validation. Yeah, the same goes for the Sybase. So it has got its own niches, but it really follows the same. For example, if you see this Unitext and text, right? So that is again Unicode LOB, and that you should either convert to your PG native text or PG native LOB. And image, so and timestamps. So interestingly, you have to choose byte here sometimes to be careful about all the information that it is holding. So that needs extreme care. These are some things that we have observed in our migrations of Sybase and SQL Server. Yeah, I think let's also deal with the case sensitivity part now.
Yeah, so I think related to so the sometimes when you are migrating from SQL Server or Sybase to Postgres, right? It's also important to really look at the default behavior or table specific behavior, which can be really adjusted in these databases, right? So like when you do a select star from table where name equal to, let's say, uppercase A, lowercase v, lowercase I, right, which is Avi, my name. So now if it's case insensitive, even if my name is stored as lowercase avi, it will still be able to fetch that result set and show you that. And if that's what is the behavior that the application is really expecting, right, then you have to be able to mimic the same, right? So if you start mapping the data types and not really handle that behavior, then that will be challenging. But at the same time, I've also seen people directly using CI text, which has got its own challenges too, right? So I think because majorly Postgres is case sensitive by default, so when you apply a where clause, probably you get 0 records, and it feels that the application probably assumes that there is no person like Avi, right? So so that's why again, it's important to know some of these concepts which are challenging. And anything that you want to add, Michael, on this?
No, I think yeah, just be careful on the collation that you choose. So particularly when you are dealing with the I18N, right, the internationalization standards. So what the collation, and then most of the time it is data driven, so we need to do rigorous testing. So we are it's better that one should maintain their own set of cases that they usually observe. So the German accent letters, so they are really troubling when you try to migrate. I think most of them have gone through it. And even this also the collation also affects the sort order. So that shows a huge impact when you are migrating the queries as well, and you not see the same performance. Yeah, and coming to the dependency scoping. So there was one case where we are migrating a legacy system to Postgres, but the ask was to only migrate what the particular application is using. So not the entire fleet that they are operating on. So that's the reason that this is one area where we can optimize the cost. So the cost in terms of the migration time and efforts by identifying what are the true pieces that this application is using, and then only migrate that stuff in the initial versions, and then you can slowly ramp up your migration area. So what we did, we went through the application code, right, and then we identified the objects that were in, and then using ORM and then the SQL parameters, sorry, the SQL queries, and then you have to dig from there. You have to do a dependency resolution. Right? So you just need to go to that definition and see what are the next level that they are calling. So application might call A, but A might call B and C, and then C can be calling D. So you have to resolve all these as a dependency graph, and then you should clearly separate out the scope and remove what can be easily replaced. So this whole exercise of extracting what that application needs was really interesting for us, because this accelerated the migration from months to weeks.
Yeah, and at the same time, you may have some dependent, some catalog tables or metadata tables which actually expose some information about what objects are scanned in the last certain amount of days, depending on the monitoring and diagnostics that you're enabling, right? So you see some of them, but that's not just everything, because you may have some tables or some code objects which probably will be queried once in a year for reporting purposes, right? So it's always important to scan the application code, like Michael said. And there are also certain interesting behavior challenges when it comes to indexes, right? For example, Sybase, SQL Server, they do allow duplicate indexes, but with respect to indexing, right? So if you talk about Postgres, the naming convention of indexes do matter. You cannot have the same, you cannot have an index with the same name on another table in a same schema. So what it means is there is no possibility of index name duplication for different tables, even though they are of different tables, but as long as they are part of same schema, you should not be able to do that. But Sybase and SQL Server allows that, right? So if you have any, very hard-coded logic which is actually doing some maintenance operations or some other activities, right? And if you try to just do a blind transformation of that, then that could start failing because you would be renaming the indexes. So it's also important to eliminate the duplicate indexes and as much as possible the never used indexes, because you are improving the migration time, and at the same time you're also improving the performance majorly right after migration, and even the data migration performance, right? So lesser the indexes, of course, better, less heavy the writes. Yeah. So this is one of the extension that we will be we'll be announcing pretty soon. Which is MS SQL phase, where we are even adding more and more, right, functionalities. But you do have Babelfish, but again, Babelfish is again one of the I would say, though open source, I think we are still waiting for the community to accept some of the interesting patches to make it possible for us to use Babelfish, which is one of the extension probably available now with Amazon Aurora. Though it's open source, we can always apply some of the patches to community Postgres, create your own fork, and still use the Babelfish extension for some of the compatibility, right? And maybe the next slide.
Yeah. So regarding so for some of the other features that you might be leveraging the other extensions. So we just talked about CI text and L-tree. So for the case insensitivity and the hierarchical query. But a PG hint plan is like you force a plan on that query.
Yeah. Anything else that you want to add on the Babelfish, Michael?
No, I think we.
Yeah, it's ultimately, I think we said a lot, but I doubt that unless you are migrating to AWS Aurora as of today, I doubt that anybody would be really using it. I probably someone like Jim may let us know if in case there is some interesting, or maybe they should be able to let us know if in case something else is going to happen towards community Postgres. But yeah, right. So yeah.
Yeah. So I would say a proper assessment would properly direct. So whether we should what path we should choose, and for easy, I would all agree for easy to medium migrations. I think Babelfish is to go right now. And for hard migrations like CLR, linked server, SQL agent jobs, that where we should think about alternatives. So, yeah.
Yeah, and some more interesting observations that we had in SQL Server to Postgres migrations is that developers are so creative about sometimes being so creative about object naming conventions. So we have seen schema names starting with hash, table names starting with dot, apostrophe, double quotes. These are some of the interesting naming conventions that developers could probably be creative about, so that nobody else touches those tables, but it will be slightly challenging when you are migrating. But when we started developing our migration tool, we ensured that we give that compatibility, because people started complaining when we try to report those. But yeah.
Correct. So I think the slight difference of MS SQL phase from Babelfish is so that's providing more on the compatibility layer. So just you drop in replacement for the compatibility, but MS SQL phase will be heading towards the performance perspective. So what the underlying data types should change, the underlying indexes should change. So we are moving in that direction. I think, yeah, that's what summarizes this slide.
Yeah. Okay. Probably you might want to give this kind of so we actually did a compatibility assessment around a okay, what are those SQL Server built-in functions which have Postgres equivalent, and at the same time some of the mappings that are possible with a little bit of a workaround, right? And for both SQL Server and Postgres, and at the same time with all of the assessments that we have done in the recent times, which probably are pretty large in number, we try to scrape the commonly observed list of functions, and for those we did a compatibility assessment to see how much of percentage is actually possible with Postgres, and at the same time which is not at all possible with Postgres. So mostly observed migration relevant built-in functions. Based on our assessment, we saw 89% of SQL built-in functions, SQL Server built-in functions have equivalent.
Yeah. So these 89% is with some efforts from our sides. So
yeah,
with all the extensions and with all the guidelines. So this is what we have observed. The main key insights are most of the window and analytic function, like other databases, they are much compatible and performant too. And same with math functions, 83%. There are few missing, but we do not really see them using much in the production databases these days. And date and time functions, so these have its own quirks, dealing with intervals and timestamps and time zones. So we should be carefully handling them. And the important gap where we identify the SQL Server special variables, the double @ error and the double @ transaction count, right? So you should either convert that to exception blocks and get that information, and then you have to just preserve the logical flow. So this is where sometimes the exception blocks just go deep into the nested calls. They go out of context, so in accessing some variables. Most of the hard part is with this system functions. And here are the numbers, and you can see the string, date, time, math, aggregate. So these are what we generally use. So they have got really good compatibility with some quirks. This is the same for Sybase. Yeah, and the same. So window functions and math functions are really good, and data and time, so needs some special care. And then security, like the RBAC concepts, and then the row level security features are other divergent factors here. So you need to put some extra care to get them in line with Postgres standards. Yeah, and there are very Sybase specific things related to the page management and licensing, and regarding to the large object APIs. So they are very different from Postgres. So they need significant custom code to match the compatibility. So this is the overall picture. So as you see, so the trend is same, but the SQL Server so slowly adopted the ANSI standards to match the Postgres. Sorry, adopted the ANSI standard. So that's why we see a better compatibility for most of the frequently used functions. And yeah, so we are bridging this gap with our MS SQL phase extension. So you could probably see better figures in the next conference.
Yeah, why did we choose MS SQL phase? Is because there is Ura phase, right? So, so there is an extension called Ura phase, which is giving some amount of compatibility. So we just thought, okay, maybe someone in Postgres might understand that, okay, MS SQL phase means probably, yeah, SQL Server compatibility up to some extent, right? So, yeah. But yeah, it will be Postgres license. So. Yeah, and some of these string functions and datetime functions and math functions that we generally observe, and what we map it to, right, between Postgres. I don't think we have to really go pretty deep into it, but yeah, I see people taking pictures. But yeah, so these are some of the migration patterns that you might want to watch out. Yeah, and at the same time, concatenation, SQL Server uses plus for strings, and Postgres uses the double pipe, right? So yeah, you still can add the operator using which is what MS SQL phase does. And any other interesting case, because I see everything basic.
Yeah, so some extended functions here. So related to JSON, JSON functions and analytical functions. So yeah, but the JSON compatibility in Postgres is much richer, uh, particularly the indexing capabilities and the ability to retrieve the key that is deep inside the JSON. We did a internal benchmark, and then obviously Postgres is catching up to whatever is the state of the art on JSON data types. And yeah, so for try cast and try convert gap, so you have to write that with exceptions. So most of the functionalities that are very conservative to the SQL Server and Sybase, most of them were covered with exceptions, but that needs to significantly follow the control flow of the variables, the data flow, and the semantic equivalence, the sub-transactions, and the transaction semantics. So this is where the real problem is. It is not with the queries or not with the variables. It is when you bring in the exceptions and just change the layers of calls. So that's when you need a very deeper care in understanding it. Yeah, I think pretty much everything.
Yeah.
So yeah, these are the hard gaps that I'll try to summarize in SQL Server to Postgres. So this try cast, try convert, try pass. So these are, you try and then you might get an exception. So you can emulate the same behavior in Postgres here with exception blocks. And then error line, state, severity, procedures. So this is all you should inspect the SQL state and then the variables to get the same information out from the blocks. And as just discussed, these system internals, this double underscore variables, so this sometimes can be easily used with variables, but most of the times we would be requiring custom exceptions, blocks, and then capturing that context. So data operations, so this is use compress, decompress the partitions, and aggregations. So you can see here the grouping ID can be converted to our bitmask implementation and check some aggregations into our XOR. But most of the time, not just the once we convert, we also saw a huge bump in the performance as well. So almost the same applies to Sybase, but the hardest part here is the Sybase was most focused on the RBAC and more audit related things were there. So that was a significant, but because that we noticed in Sybase, and that would require our own RBAC and security features. That's the best, because that's how you prove in audits, the migrated code audits, that it works the same. And the large object related things, store, I think we covered most of them here. So yeah, but one thing we have noticed, all the queries are mostly compatible. So the 94% of the queries were not the problem at all. The problem was the other little semantics that's mentioned here.
Yeah, yes. So there are a lot of I mean, when we were trying to do this assessment, right, we skipped migration irrelevant standard functions too, and I would not really say that migrating from SQL Server to Postgres really introduced you to a lot of challenges, but there will be some which do not have direct equivalence, but it does not mean that it cannot be handled. So there is always an opportunity to map it to certain alternative in Postgres. So 95% plus are always portable some or the other way, and we probably may have to make some adjustments to the application in the other ways, in the other cases, right? So yeah, you could go ahead.
So here are some schema conversion differences. So the object name spacing, right? So the DB was default there and public is here. So it's simple. And index name scope, what just Javier mentioned. So they're all unique for table. The indexes in SQL Server and Sybase, so they are unique per table. But when you come to Postgres, it is unique per schema. So that's it is most commonly expected thing that you see in SQL Server and Sybase migrations. An identity column, so it's better that we use our own DDL, so generated by default as identity. And partitioning, so but Sybase was only supporting the basic round robin, at least the version that we tested, and the Postgres, so we can use our own by understanding the real data in it. And then computed columns, so the generated columns, and check constraints, so we can I think every Sybase has a column validation rules, which is very similar to the native checks in SQL Server and Postgres, so the ANSI standard. And the clustered index, so here physical.
It's about the ordering of the so how we want to really order the heap, right? So so should the rows be ordered in the order of a certain column which is indexed, or while you have the equivalent, there is no equivalent basically in Postgres. You have the cluster command which can do that, but as long as you start doing any updates or deletes, you cannot really guarantee the order, but that probably may be applicable for append only tables still, right? As long as the first column is what is the or the primary key is what is the column using which you are clustering.
Yeah, and so we have left a very important note. So these index name conflicts are very more often than you expect. So be careful in what are the naming conventions that they sometimes use the dot itself, or they might use dollars. So they all really be painful later in dynamic SQLs. Okay, so later, because yeah, they all remove the sanity, and then it will inject the possibility of SQL injection. So all these things are really a pain point. Yeah. So I think this is the same. So we are just putting. So this is a SQL Server path that we usually go with. So most times we'll the try catch should be converted to begin exception, and then the table valued parameters, we do not have direct equivalence, but we can use temporary tables or array parameters, our own composite type arrays. So each has its own trade-offs. This requires a significant understanding of the code base and data. And now the PG has merge, but it has no output clause. So we thought the merge would be directly compatible. Then there's also output clause. So you have to use the on conflict with returning, so that you will also get the what the output clause were offering. And then or you can use CTs. So cross database queries, so we can use FDWs, DB links, so all that stuff. A dynamic SQL, I think it's pretty straightforward, and we should prefer parameterizing the dynamic SQLs. And temp tables, so currently we do not have global temporary tables, but we have PG.
Yeah, but basically the PGTT extension that we do contribute to gives a similar compatibility as global temporary tables, right? However, one of the things that I want to talk about temporary tables is, again, the developers' innovation around basically SQL Server really does it well, probably, right? So we create a lot of temporary tables. So I see that, people in stored procedures or functions, we see like create temp table as select star from some table, and then create temp table as select star from the temp table join with another table, and then another create temp table. So technically there were instances where a 2000 line code object with probably 20 odd temp tables was trimmed to a 30 line code during migration, right? So and that was really working well in SQL Server, interestingly, right? But when it comes to Postgres, probably you will have some fun time. So so I think so it's good to have a direct conversion that way, but it's always important to watch out for optimizations that can really happen for Postgres. And even related to cross database queries, it's important that we also try to have such kind of cross database queries unless it is done for a specific purpose. But if it's more frequent than for a transactional system, it's always important to see how we want to collocate those schemas and try to scale the database system for high performance instead of really distributing and decomposing the schema to multiple different databases. Just because SQL Server is a different design altogether, architecture altogether, so that probably is heavily performant. So Postgres FDW exists, but you would always want to avoid that join involving a lot of data movement between two different databases, right? So
correct. And this reminds me one more thing about temp tables. So most of the temp tables are the staging tables, right? The data just flows here. They were just logically separated. It works well with the SQL Server there, but it works terribly in Postgres. So you create a table, dump there, drop the table, command lot of DDL commands, right? So we observe that CT, most of the things can be replaced with CT in the business case. So CT was performing better in terms of query planning and everything. So that was one point we missed to add here.
Yeah, I think we are almost out of time, but if you quickly want to cover anything.
Yeah, so I'll quickly complete the Sybase path as well. So there are no try catches. You just execute and then watch out for the error variable. So you can do the same with PL/SQL, and the raise error can be can be converted to raise exception, and then there are implicit result sets. So now we require return table, return set of ref cursors and everything to take the table out there. So but they just do it by select from the pod body. And all this ANSI related pre-ANSI syntax should be converted to the ANSI syntax. So compute by has to be converted to grouping sets or the window functions. Transaction nesting, so this is what we are talking. So it's tricky when again all the rollbacks and save points and checkpoints come into place. So yeah, I think we have covered everything. Just put in a slide, you can take a snap here. And application layer challenges.
Yeah, so some of the things that you probably have to see as a developer, the driver behaviors and connection pooling, because SQL Server is thread based and PG is process based. So you'll have to probably introduce a server-side connection pooler if you do not have an application-side pooler, right? And be careful about the ORM generated SQL, right? And you'll have to really test it and ensure that you need to tune or optimize any of the other patterns. But I think, yeah, so some of the things like bulk copy command in Postgres and unnest and multi-row insert. So these are some of the things probably you will come across when you are finding alternatives for some of the operations in Postgres. But it's good to know the mappings, and yeah, some of the mappings that we have discussed until now are shown, are relevant. So I think I wanted to talk about a little bit about how CDC works internally, but the thing is, I'll quickly close by saying something, right? So especially with respect to Sybase, it's pretty challenging to perform CDC because there is a proprietary format, and you can really use dbcc log, which is some kind of tracing, and you'll be able to and the way you decode the CDC events for APL versus DOL is different. We were able to extract that. We really were able to build our custom CDC connector for Sybase. SQL Server, you have the built-in CDC agent, so the approach is really simple to enable the replication from SQL Server. But Sybase, yeah, excuse me. So if you have to implement something like that, it will be tough. But we have done it. So in case you want to get that CDC connector from us, absolutely reach out. But yeah. And yeah, some of the statistics, metadata tables, etc., that you can use, MDA tables, or the other source metrics that you can really see in order to get some SQL Server metrics. Which data? I mean, in order to tune some of the Postgres configurations, you might want to see some of these metrics and estimate work mem or shared buffers, right? And but some of these other parameters which you generally tune can be just tuned based on the general understanding of Postgres. And for high availability, etc., backup and recovery, you have interestingly compatible as well as or even advanced tools and open source tools and extensions, Petroni for high availability. You have row level and column level security, as well as PG backrest and a lot of other backup and recovery tools, right? So I think, mostly with respect to admin or other general requirements, I think you have better compatibility, better features in Postgres, majorly from admin perspective, administration perspective, and authentication or security, right? Yeah. Anything else after that? Yeah. So just assess, convert, prepare, migrate, cut over. So some of the stages that we generally say, right? So it's important to understand the compatibility between the two systems and dependency mapping, and then estimate your efforts, and then convert your schema, refactor, because you may observe some of those functionalities that needs to be optimized for Postgres, and then prepare your Postgres environment, migrate, and do the cutover. You also got a tool which actually does DMAT, which is going to do that assessment for you, and also HexaRocket, which can do that end-to-end migration, which is online migration, including rollback, and 100% schema conversion, right? And you also have some of the extensions that are going to give you the SQL Server compatibility, but yeah, I do not want to talk anything much about our tools in this case, but yeah, CDC for Sybase is fundamentally harder than SQL Server, but I would suggest not to build this. We took more than 2 months to decode that, and other than that, yeah, so mostly everything is what we discussed, but if you need any help with SQL Server and Sybase migrations to Postgres, please feel free to meet us. We have a booth, and yeah, thank you.
Thank you, team.